A major clinical trial, 25,871 participants, conducted by Harvard researchers, found that people who took a daily vitamin D3 supplement showed telomere preservation equivalent to 3 years less biological aging compared to those who took a placebo. Not turning back the clock, slowing it down. That's not a supplement company's marketing claim. That's a randomized controlled trial published in the American Journal of Clinical Nutrition in May 2025. So today, we're going to break down exactly what that means, how the study was done, and whether you should actually be taking vitamin D3. First, a quick but important clarification that most people get wrong. Vitamin D is not actually a vitamin in the traditional sense. It's technically a precursor to a steroid hormone called calcitriol, which then acts on receptors throughout almost every tissue in your body, your immune cells, your heart, your brain, your bones. So when we talk about vitamin D, we're really talking about a signaling molecule with wide-ranging effects on how your body functions. Now, your skin produces vitamin D when exposed to UVB radiation from sunlight. That sounds simple enough, but the reality is that a large proportion of the global population is deficient, and that includes people who live in sunny climates. Factors like sunscreen use, time spent indoors, skin pigmentation, body weight, and age all affect how efficiently your body makes and uses vitamin D. Dietary sources exist, fatty fish, egg yolks, fortified foods, but it's extremely difficult to reach optimal levels through diet alone, which is why supplementation is so widely recommended. The two main supplement forms are D2 and D3. D3, cholecalciferol, is the form your skin naturally produces, and research consistently shows it's more effective at raising and maintaining blood levels. So when we talk about supplementation, we're talking about D3. To understand what this study actually found, you need to know what telomeres are. Bear with me, this part matters. Inside almost every cell in your body, your DNA is packaged into structures called chromosomes. And at the very end of each chromosome, there are protective caps called telomeres. Think of them like the plastic tips at the end of a shoelace. Their job is to protect the chromosome from fraying and degrading. Here's the problem. Every time a cell divides, those telomeres get a little bit shorter. Over time, over decades, they shorten to the point where the cell can no longer divide properly. It either dies or enters a dysfunctional state. And that process, at scale, is one of the hallmarks of biological aging. Scientists use telomere length as a marker of biological age, not your age on paper, but how much actual wear and tear your cells have accumulated. Shorter telomeres are associated with accelerated aging, higher disease risk, and earlier mortality. Critically, telomere shortening is not just a clock you passively watch. Emerging research suggests it can be influenced by lifestyle factors, by chronic inflammation, and as this study found, potentially by supplementation. The study is called the VITAL trial, the vitamin D and omega-3 trial, and it is one of the largest and most rigorous supplement trials ever conducted. 25,871 men and women, men aged 50 and over, women aged 55 and over, randomly assigned to take either 2,000 IU of vitamin D3 per day or a placebo, run over 5 years with telomere measurements taken at baseline, 2 years, and 4 years into the trial, overseen by researchers at Harvard's Brigham and Women's Hospital, with the telomere sub-study co-led by the Medical College of Georgia. For the telomere component specifically, researchers looked at a subset of just over 1,000 participants who were close enough to Harvard's clinical center to have their blood drawn at each of those 3 time points. Those blood samples were used to measure telomere length. What they found was this. Both groups experienced telomere shortening over 4 years. That's expected. That's normal aging. But the vitamin D group lost significantly fewer base pairs than the placebo group. Specifically, 140 fewer base pairs on average over 4 years. The researchers translated that into real-world terms. The vitamin D group appeared to have undergone the equivalent of approximately 3 years less biological aging than the placebo group. Dr. Joanne Manson, the trial's principal investigator, called it the first large-scale, long-term randomized trial to show that vitamin D supplements protect telomeres and preserve telomere length. That's a significant claim from the person who ran the study. Worth noting, the trial also tested omega-3 fatty acid supplementation alongside vitamin D3. Omega-3s showed no significant effect on telomere length, so this finding is specific to vitamin D3, not a general supplements slow aging story. Now, I'm a nurse and I'm not going to skip the caveats because they matter. The telomere measurements were taken from white blood cells only. That's a practical limitation. You can't easily biopsy telomeres from heart muscle or brain tissue. Whether telomere preservation in immune cells translates directly to broader aging outcomes is not yet fully established. The telomere sub-study involved around 1,000 participants, a meaningful sample but a fraction of the 25,871 in the full trial, and as one expert quoted in the coverage pointed out, it's only at the extremes of telomere length that the clinical impact becomes very clear. In plain terms, we know vitamin D preserved telomere length. We're less certain exactly how that translates to real-world outcomes, like how long you live or how healthy you are at 80. So this is genuinely exciting, well-designed research, but it's one piece of a larger picture, not the final word. What it does do is provide a plausible biological mechanism for something researchers had already been observing in the vital data. Vitamin D was also associated with reduced inflammation, lower rates of advanced cancer, and reduced autoimmune disease. The telomere finding may help explain why. So, should you be taking vitamin D3? Based on the current evidence, a strong case can be made for most adults. The VITAL trial specifically enrolled people over 50, but vitamin D deficiency is widespread across all age groups, particularly those living in low sunlight climates, those with darker skin tones, or anyone spending most of their time indoors. The dose used in the VITAL trial was 2,000 IU per day of D3. That's a commonly available, well-tolerated dose. It's what I personally take as part of my own supplement routine. That said, I'd always recommend getting your levels tested first. A simple blood test measuring 25-hydroxy-vitamin D gives you your actual status. General targets in the literature vary. Mainstream guidelines often cite 20 to 30, while some researchers argue for 40 to 60 nanograms per milliliter for optimal health. If you're already in a good range through sun exposure or diet, supplementing on top may offer limited additional benefit. If you're deficient, which many people are without knowing it, bringing those levels up is likely worthwhile regardless of the telomere data. As always, talk to your doctor before starting any new supplement, especially if you're on medications or have underlying health conditions. Vitamin D toxicity is rare, but possible at very high doses over extended periods, which is why testing and appropriate dosing matters. To summarize, the VITAL trial found that 2,000 IU of vitamin D3 per day preserved telomere length by the equivalent of approximately 3 years of biological aging compared to those who took a placebo. It's one of the most compelling supplement findings of 2025, and it came from one of the most rigorous trials ever run. If you're not getting your vitamin D levels tested, start here. It's a simple blood test, and it might be the most useful thing you do for your long-term health this year. If you found this useful, subscribe. I cover research like this regularly, breaking down what the actual studies say rather than what the headlines want you to believe. I'll see you in the next one.